Hello guys, good morning. Welcome to the theory of vibration and aeroelastic lecture series. So today we are going to see the aeroelastic phenomena. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. So today we'll see the aeroelastic and the collar triangle, necessary of aeroelastic phenomena, and history behind the understanding of aeroelastic studies, classification of aeroelasticity, precautions, and further development of aeroelasticity. Introduction: Aeroelastic is a study of interaction between the inertia force, structural and aerodynamics of aircraft, airplanes, buildings, and surface vehicle. This triangle is a combination of inertia force and aerodynamic force makes the flight dynamics, and inertia force and structural force makes the structural dynamics, and structural force and aerodynamic forces makes the static aeroelasticity, which is outer bounding, and inside this combination of all these three, inertia force, structural force, and aerodynamic force, the dynamics aeroelasticity. Necessary to understand the catastrophic effects, study of aerodynamics in rotor engine, rotor design, windmills and wind generators, and wind energy studies, and high speed operation of aircraft wings. And bit of history, we can understand the control surface flutter becomes the frequent phenomena during the World War I. It was solved by precise mass balancing around the control surface engine line. So in example of sees the aeroelastic phenomena, Hadley Page 04 elevator fuselage makes the understanding the aeroelastic phenomena. Junker JU-90 fluttered during flight flutter test. P80 F100 F14 makes the aeroelastic flutter during transonic aerofoil bus. T46A the servo tap flutter producing element. F16 F18 extender stores LC0 buffeting makes. F111 external stores LC0, and F17 E6 vertical fins produces the flutter. These are the cases we can understand the aeroelastic phenomena and flutter and buffeting produces during the various operation conditions. Here the flow chart shows the different categories and classification of aeroelasticity. Two categories we can categorize the aeroelasticity. One is static aeroelasticity and dynamic aeroelasticity. In static aeroelasticity, we can understand the divergent effect and control reversal operation, whereas in dynamic aeroelasticity, it produces fluttering of components, buffeting of surfaces, and transonic motion of control surfaces. In aeroelasticity, we have static, which deals with elastic or steady response of an elastic body over the fluid flow, which affects divergence and control reverses. In dynamic condition, which deals with the body in dynamic response, there the effect will be flutter producing, buffeting creation, and transonic aeroelasticity. First, we'll understand the static aeroelasticity. Divergence is a phenomena in which the elastic twist of wing suddenly becomes theoretically infinite, typically causing the wing to fail suspectorily. Control reversal. Control reversal is a phenomena occurring only in the wing with ailerons or other control surfaces, in which these control surfaces reverse their usual functionality during operation. Dynamic aeroelasticity produces flutter. Flutter is a dynamic instability of an elastic structure in fluid flow. Causes positive feedback between the bodies, deflection, and the force extended by the fluid flow. Here we have the two examples of empennage is flutter during the dynamic instability, and Tacoma Narrow Bridge fails due to the flutter effect, which the causes by the aeroelastic phenomena. And buffeting, high frequency instability causes by airflow separation on shock waves oscillation from one object striking another. This produces the buffeting of wing. Buffeting causes sudden impulse of load increasing over the wing surface, which generally it affects the tail unit of the aircraft structure due to airflow downstream from the main wing. In transonic aerosity, the phenomena that impacts stability of aircraft known as transonic dip, in which the flutter speed can get closer to flight speed. Location, aerodynamic design, divergent, flutter, control reversal, wind tunnel testing, aerodynamic scaling we can do, ground vibration tester, complete model analysis of aircraft structure can we can do by reducing this flutter effect. Flight testing, flutter testing demonstrate that flight envelope flutter free operation. Here I have referred this papers, Fisher design of composite beams and Wanger of steel composite structures. It helps me to understand this flutter analysis. We'll see the remaining topic on next class. Thank you.